Welcome to another edition of TriStar's Creo Series live webinars. My name is Shawn Schreckengost. I'm a Business Development Manager and Application Engineer. For this series webinar, we are going to feature how to use the Intelligent Fastener extension in Creo Parametric 3. So for this 30-minute webinar, we're going to show you how to expand the hardware fastener functionality in Creo Parametric using the Intelligent Fastener capability to automate assembly of fasteners and hole creation in components. Also to reduce part proliferation by using customizable fastener libraries to drive standardization. Improve design workflow and automate validation checking of fasteners. This webinar is being recorded. So the Intelligent Fastener extension, IFX, allows us to quickly assemble fasteners and create holes in our parts or models. Okay? Using traditional modeling techniques to create a hole in each part and assemble a socket head cap screw will take the average user at least 35 mouse clicks and approximately 96 seconds. Using the Intelligent Fastener extension, this automates the creation of holes and assembly of fasteners with a single user interface, reducing the workload to 11 mouse clicks and 19 seconds, approximately. This is an improved workflow. With little or no training, any Creo user can utilize IFX to assemble fasteners. There's an easy-to-use interface that allows the user to define the position of the fixing by selecting either a datum point, datum axis, hole surface, or by a mouse pick. The first thing to do is, after selecting the axis or location, select a plane to locate the screw head. Select a plane to locate the nut or end of a threaded hole. Define the desired fixing configuration from the comprehensive out-of-the-box library. Then with placement and hardware configuration defined, IFX will automatically calculate the fastener length, create the required holes at the part level, assemble the fastening hardware, prompt to pattern if selected references are patterned. After design changes, IFX also provides tools to check whether fasteners are long enough, check holes are aligned with fasteners. Some of these options are available with the full version of IFX only. So we do have some library limitations. The light version comes with Creo Parametric out of the box. Okay? With that, we get a comprehensive library of screws in millimeters and inches. We get washers also in millimeters and inches, and also nuts in millimeters and inches. With the full extension, you also have the ability to assemble dowel pins with millimeters or inches. We can customize the library. We can create screw configurations and support multiple fasteners of the same size, but without differing or with differing sub-information. As far as placement and validation limitations, again, with the light version, we have automatic hole creation, counter bores, automated length selection, automated thread diameter selection, and pattern fasteners during placement. With the full version, we can assemble fasteners on all points or axes, create holes without external references, alignment of fasteners on beams with sloped inner surfaces, assembling nuts to subassemblies, and with validation, updating hole positions and fastener length. So in summary, we have improved standardization with comprehensive library of fasteners, improved user productivity, at least 90% quicker, and 68% less mouse clicks. If we delete the fasteners, this will automatically delete any associated holes that were created during the assembly of the fastener. We have improved design workflows with the automated creation of holes without assembly references. Again, this is with the full version only. And improved design accuracy with the verification tools to check and fully aligned mounting holes. Again, some of these options are available with the full version only. With that, let's go ahead and start our demonstration. All right, so I have a pretty complicated assembly with a lot of places where we want to create some holes, or some fasteners, I should say. The first thing I want to do is I want to put a bolt that assembles these two housings together of this gear housing. Okay, we have some axes that locate the screws for us, so we'll use those when we assemble these fasteners. So the first thing we want to do is go to the Tools tab, and here you'll see the Intelligent Fastener dialog. In this, we have the ability to assemble screws at either a point or axis, or assemble by mouse pick. With the advanced or full version, we can assemble dowels on points or axes, or also by mouse picks. And then we have the ability to reassemble, redefine, and delete. And there are some additional options in the drop-down to check the screw fasteners, update holes, suppress and resume, even set our options for the Intelligent Fastener insertion. So what I'm going to do here is I'm just going to use the default assemble on point or axis for a screw. And in this dialog, it asks us to select an axis for the location, a surface for the screw head, and a surface for the nut head. With that, we've defined everything we need in the references dialog, so we'll go ahead and hit OK. With that, we've got the fastener definition dialog. In here, we have a catalog of fasteners, millimeters and inches, and various different structural properties. Okay. In this case, I'm just going to stick with the default millimeters. And then we also have the ability to select a screw off the dialog. In this case, I'm going to select the screw ISO 4014-8.8. This one right here. Okay. While we're assembling this, we can actually view the 2D preview in the dialog so that we can see what is actually happening here. We can also preview on the model in wireframe. And obviously, this screw size is not the correct screw size. So what I'm going to use is the M12 from the screw size dropdown. Okay. And we can see that our preview is updated accordingly. With this, I have the options to put washers on side 1 and side 2, and we can have up to 2 washers on each side. Maybe we want a flat washer and a lock washer, or some configuration like that. In this case, I'm going to use side 1, and I'm going to select the DIN EN ISO 791. Okay. And we can see our preview is updating accordingly, and we'll continue with a washer on the side 2. So in this case, I'm going to use the DIN 127-B. Okay. And again, our preview updates. We're also going to put, actually, let's put this lock washer as the second washer. And then for our first washer, we'll just use the same washer on the top side, the DIN EN ISO 791. And again, notice our preview is updating for each pick that we do. For the nut, I'm going to use an ISO 4032-6. That's already selected. That's the default. So what you'll notice here is that the screw length has been selected for us. However, it doesn't match the required length. So we have options to set the length here, or we can automatically set the length based on the required configuration. And that's what I'm going to do with this situation here. As you'll notice, my screw length updates. I've pretty much defined everything I need for this fastener, so I'm going to go ahead and say OK. Now, considering that that axis that I chose was part of a pattern, I have that option to reference pattern that fastener, and that's what I'll do. Now, with that, we have fasteners on all locations of that pattern. And if we open one of these housing covers, we'll see that we now have a pattern of holes created for that fastener. Okay? So all the work is being done for us. All we need to do is select the appropriate references, and the fastener gets created. The next fastener I'm going to create is going to be in this plate right here. So what we'll do is we'll go to the screw dialog. We'll select the axis of the hole. We'll select the surface for the screw head. And this is going to be a threaded screw. So we're going to go ahead and select this reference right here, which is the surface to be drilled and threaded. Okay. With that, we'll say OK. And then we'll select the appropriate screw from the dialog. In this case, I want the 4762-8.8. We'll also use the measure diameter of the hole to select the appropriate screw diameter. So I'll use the hole that's existing here, and we'll select that. You'll notice that the screw selection went from M12 to M10. We also can set the depth. In this case, I'm going to set the depth to 25. You'll notice that my preview again updates automatically. Also, the preview in the model updates. With this, we'll say OK. And in this situation, because we have two housings that come together, both of these need to have instances created. So pattern will work only on the whole surface that we selected, meaning this part here would only get these threaded holes. So in this situation, since we have two parts that need to be threaded, we're going to say assemble fastener on all instances and say OK. And here you can see that if we open this part again, that we have threaded holes created in this part. And the same thing with the bottom housing as well. All right, let's go ahead and assemble that same fastener in this plate here. You'll notice this plate does not have predefined holes, so we'll have to create the holes in this situation. So I'm going to go ahead and say assemble a screw again. I'll select an axis off this part. I'll select the surface to drill through, and then the surface to be threaded, and we'll say OK. In this situation, we'll use the same screw that we had before with the same size and the same depth. And we'll see how that looks. And again, we'll use a pattern, and this works since we're only screwing into one hole, or one part, I should say. Now in this situation, it looks like I may have used too large of a screw. So I can very easily redefine this and select one of the screws and specify, in this case, a new thread size. I'm going to use the M8, and I'm going to set my depth to 20. In this situation, we'll see the preview show up on the model. However, the original screws are not removed yet until I say OK. And then again, we'll pattern the fastener. And there you can see I very easily changed the size of the screw configuration. For our next option, we're going to put some fasteners in this location here. And this is, already got an existing hole, but we're going to bolt this to this I-beam. And one thing I want to point out is the I-beam has a sloped surface on the back side. So we'll have to consider that when we assemble the fastener. Okay, so in this case, we'll go again with this simple screw. We'll select the axis as a reference. We'll select the surface for the nut. And in this case, excuse me, for the screw head, this case for the nut, we'll select the back side of this I-beam, which is sloped. And you'll notice that the arrow for the location of the nut is also normal to that surface. We have the option to align or select an orientation for alignment, and I'll select this surface here, and there you can see the arrows for the nut are now parallel with the arrow for the screw. So we'll say OK here. And in this situation, we want to use a 417-8.8. We'll use the measure diameter to determine the screw size. We'll select a washer for the top side, DN 433-1. And also for the bottom side, we're going to use a 435-I. And this is a sloped or tapered washer, if you will. And then for the nut, we're going to use the DIN 6923-10. And then we'll measure the length. I like what I see here. My preview looks good on both the model and in the dialog, so we'll say OK. And in this situation, using pattern, we'll pattern this configuration. However, the washer on the right side will show up in the wrong location. So it's just trying to pattern the axis and keep everything in the same orientation. So what we're going to do is assemble the fastener on all instances again, and this will correct that situation. Okay, and here you can see how that configuration is assembled with our tapered washer on one side and the tapered washer on the other side. Okay, now what I want to do is assemble a dowel pin. Okay, and I'm going to use this axis right here. So we'll say assemble dowel pin. We're going to use this axis. And in this case, the placement surface would be the surface between the two parts. So we want this surface right here. And we'll say OK. So with the dowel pin, we have a few other options. Okay, we have the dowel pin that we want to use, the diameter, the length, and the depth to be inserted into the hole. Okay, in this case, what I'm going to do is we'll use the 2338-M6-ST, which is the default selected. We'll say our diameter is 8. We'll show the preview on the model so we can see what's happening. We'll say our depth is 20, or our length is 20, I should say. And then if we look at the flyout for additional options, we have the choices of how to create the hole types. In this case, we don't want a through hole for a dowel pin, so we're going to say that we want a blind hole. Okay? And in this case, we'll say the depth is 10.5 to accommodate the length of the dowel pin. And we'll do the same thing on the bottom hole, and it's also going to be 10.5. If we like what we see, we can hit OK and pattern the fastener again. I think there's another situation or instance over on the other side of the model, so we'll say OK. And in this case, I'm just going to hide this top housing so that we can see what happened here. And there you can see our dowel pin was created in the hole and located on the pattern. Okay. In this case, I also want to take a look and make sure everything that I've got is assembled correctly. Just make sure anything needs to be adjusted. In this case, I think maybe this screw might be a little bit too large. You can see it's kind of buttoned up against the housing in a couple locations. So we'll redefine that. We'll select one of these screws. And I'm just going to change the size from an M12 to an M10. We'll measure our length. We can also set this by selecting the drop-down if we feel the measured length is too long. In this case, I'll just change that to 55. And we'll say OK. And again, pattern the instances. Okay. So very easily to assemble these fasteners and then make changes after the fact. The last thing I want to do is I want to assemble another dowel pin, but in this case, I'm going to use the free location or by mouse pick. So we'll say dowel pin by mouse pick. Now this works a little bit differently in where we select dimension references and then again the surface for the dowel pin. We'll say OK. And after we've specified our configuration, in this case we're just going to use the same dowel pin that we used before. I'm going to say OK. And it asks us to drop that dowel pin on that surface somewhere. So I want to kind of eyeball this and get it close to where I want it. Okay? We do have options to turn on the ability to modify these dimensions during the placement. However, we can always modify them after the fact. So in this case, I'm just going to go ahead and middle mouse button out here. We'll see that that fastener has been assembled, so we'll hide the top housing again. Now, if I want to dial in that location, all I need to do is select the axis that was created and use Edit. And now I can manually specify where I want these to be. And then regenerate the model. Okay? And the fastener moves to the desired location. Okay? And that method of placement works the same for placing screws as well. I'm going to go in here and edit the definition one more time of this bolt. So we're going to say redefine and select this one. And I want to show you the flyout for creating counterbores or changing the type of fit for this hole. So by default, we get a close fit. Maybe I want to change it to be a medium fit in the size of the hole. I can specify manually also the size of the hole. I can also specify a counterbore. Okay? And in this case, we can specify the counterbore's diameter and depth. I like the 24 and I like the 9.4 depth. All right? So if I like what I see here, we'll say OK. And again, pattern the fastener. And here you'll notice that we've got our hole created with a counterbore in this situation. So as you can see, we have lots of options for creating these fasteners and creating the holes associated to them in the submodels. Okay. So with that, I'd like to open the dialog for questions. So in your GoToMeeting or GoToWebinar dialog, we have a Q&A section here. And so let's see if we can't answer some of the questions that are already coming in. First question, somebody joined late, will there be a replay? Yes. These webinars are recorded and can be found on our TriStar website. I will share that link with you momentarily. The next question is, does using IFX as you show in the assembly mean that the assembly is now referenced in the part that has the IFX feature? With the light version, yes, those assembly references are created. With the full version, you have the option to not create the assembly references. So if that's what you needed to do, then you would have to purchase that full version. Next question, is it possible to change counterbore hole dimension? Yes, I showed you that in the dialog. We can edit the definition of this fastener, and then in the counterbore we can change the depth or the diameter if we wanted to. Okay, so that would make it a little bit bigger. You can see in the preview that it's going to be a little bit larger, and we say go ahead and pattern. So yes, that counterbore can be changed. The next question, does the catalog contain NAS bolts? Well, let's take a look. So, whoops, let's cancel that. We'll just do a redefine on this again. And what options do we have? We have millimeters, millimeters HV, millimeters fine, inches, inch structural, ANSI English, ANSI metric, ISO, JIS, and holochrome. So if you needed NAS bolts, then you would need to perhaps have that library added, and in that case you would need the full extension. And I just want to check one other location here. Yeah. Okay, next question. Need to customize library to reference my database parts. Yes, you would have to purchase the full extension to customize the library to use your parts. Next question, do we have hard copies of this procedure? There are training materials for the procedure on PTC's website. You can look at their learning exchange as well as the prescription learning system. Next question, can you explain or talk about how these fasteners are added to the bill of materials? Yes, I mean, as you can see in my assembly, we have groups of the screws and other parts that are associated to these fasteners. So this is exactly how it would show up in your bill of materials. Excuse me. Is it possible to assign attributes, part numbers, material, etc., in the light version? You cannot assign or change the part numbers for the fasteners in the light version, so you can't assign anything to them as well. However, if you purchase the full version, then yes, you have that ability to customize your library. How to manage fastener parts in Windchill. So what happens here when you assemble these fasteners, it actually copies the fastener from the library and places it in either your working directory or, in the case of Windchill, in your workspace. So they would be automatically added, and then you can check them in. If they're already in your Windchill database, then there'd be no need to check them in. Next question. When I generate fasteners, they show up as the same color as the parts. Is there a setting to adjust the fastener color to be as yours are a different color? I believe you can change the color of the fastener after it's fastened or assembled. And let's just try that just to make sure. If I open this and I assign a color to this or an appearance, let's just pick something here. And we'll say the whole part and say OK. So that looks like it worked, and then we'll just go back to the assembly, and sure enough, we can change that after the fact. Does the fastener have custom parameters to show in a bill of material or drawing? Well, let's open that again and see what parameters are available to us. So yes, these do have some parameters. I don't know if they'll benefit your bill of materials, but these are the parameters that come with the fastener. So in this case, maybe the designation would be what you want to show in your bill of materials. Are you able to use windshield models of existing fasteners? Again, you would have to have the full version to customize that fastener library. The custom notes with the countable hole with parameters, they come in with the hole themselves. So if we take a look at one of those holes, we'll open this part, and if we take one of those holes and edit its definition, you can see that the hole, if it has any note properties, that's what you get for your detailed drawings if you need that information. As far as creating a custom library, then with the holes, I don't think you have that ability. You just have the ability to use the note that's created and either add or remove the notes. You could create your own notes in the drawing. Again, putting your own part numbers on the fasteners would require the full extension. The next question is, can we talk about the change in the design flow for using IFX? For instance, we already had an axis created for all our fastener locations. Well, as you saw during the demonstration, I showed how to create the fasteners on a mouse pick. So you don't necessarily need to have those locations predefined. It certainly works a lot easier to have those positions, but it's just a little bit more work after the fact to do the mouse pick and then pattern that afterwards. Next question, does it automatically save a copy of your fastener components in your working directory? Yes, if you were to look in your working directory, in this case, I'll show you my working directory for this. And in this case, you'll see that we have now those fastener parts located in this working directory. And you can see when they were added, actually on today's date, at about 8/24 in this case, and the other ones as well. So yes, they are added to your working directory as you create the fastener instances. If we customize some custom part with the full license, is it possible to assemble to a custom part with standard instances? Well, if you have the full version, you get the standard instances of the hardware as well as the ability to add your custom. The standard license will not allow you to use the custom library. Okay, if you only had one license of the full version, that's the license you would need to use the custom library. New fasteners parts are added to the working directory. Can we change this to a default search path location, or is there a better way to address adding multiple versions of the same parts? Well, it's only going to add one version of each part to your working directory. So if I use a screw 10 times, it's only going to add one instance. Okay? That being said, you can have a search path with all those fasteners, and then you wouldn't have to keep them in your working directory as long as you could find them in the search path. So you would have to create a search path to point to these libraries, which can be found in the install directories on your system. Or maybe if you had a separate library on a server, you could do that as well. Can rivets be configured? I don't believe at this point we have the ability to use rivets in the Intelligent Fastener extension. Okay, but I just want to double check on that. So let's go back to our assembly here. And I want to edit the definition of that dowel pin, which is be where it would be. And I don't see anything in here that looks like a rivet. I mean, you may be able to trick it into seeing rivets, but I don't think we have that option. If we already have screws set up as part numbers, can we use those instead of using, yes, you'd have to have the full version again to have a custom library. The light version uses the predefined libraries. What options are available to add shoulder bolts to the library? So if there's no shoulder bolts in the existing library, again, you would have to have the full extension to add your own fasteners. How easy is it to, or how difficult is it to replace current fasteners with this database? Well, you'd have to, I guess, delete the current fasteners that you're using and then reassemble using this tool. I can't think of any other way that you'd be able to do that. I mean, you could certainly copy these fasteners that come with the library and just use them just like they were, assembled without the Intelligent Fastener extension. So you could do that. It's just a matter of replacing one for the other. Is it possible to switch from a standard license to full without closing Creo? Well, I imagine if you had the licenses, you could go to the license management dialog and either pull or push those licenses, as long as they're on a server where everybody else could access them. If a user did not know a hole was created with IFX, how would they come to know how to change the hole location? Holes that are located or created by IFX, you cannot edit their location unless you edit the axis that was created using a mouse location. Okay, so in the situation where I had placed this dowel pin right here that has an axis, I would have to select that axis and then use edit. That's the only way to move the holes, because we have to move the entire fastener configuration at once. If I were to open this part, oops, let me open the base part here, and I tried to edit that hole, I don't get much to edit, right? Basically the depth, diameter, and the angle of the drill point. I cannot edit the location because, again, the entire configuration has to move with it. Next question is, are chains in the fastener library? Can you please show us how to enter a chain pattern? I'm not sure I understand that question. So that's from Ni or Nai. If you could please rephrase your question and give me a little bit more information. With the full version, how do you go about adding to the library? In that case, you would just have to edit the library in the options dialog to include any additional libraries. You probably want to put them in the same location as the addition or the existing libraries, just to keep everything together. Can one full ONFX license be shared amongst several users? Yes, if it's a floating license, then you can have that on the server, and then multiple users can pool that license. Okay. So I don't see any other questions. Oh, we've got one more that just showed up. Oh, chains like bicycle chains. Well, I can't say that I've ever tried assembling fasteners on a bicycle chain. I would imagine that'd be a dowel pin, and the dowel pin would need to be on a pattern of axis of the chain. So as long as, well, I wouldn't know if that necessarily be a pattern. You might be able to use assemble on all instances. Unfortunately, I don't have a chain model to try that out on, but I think that would probably work with using assemble on all instances, not necessarily the pattern. If it's a pattern, yes, it would work, but I don't see how you could pattern. Well, if you pattern along a curve, I would imagine it would work. As long as your pattern was built correctly, it should work. Unfortunately, again, I don't have a model to try that on. Okay, with that, there are no further questions. So at this point, I'm going to conclude the webinar. Thank you, everybody, for attending. I do have a few more slides to share with you. First of all, we'll start right here. We have some helpful links for you to access some additional broadcasts that are coming up. You can view the recorded webinars. Okay, there are also some topics of help, and these are typically done by TriStar application engineers. There's the PTC Learning Exchange. This is a great source for free videos that are little tutorials that cover many aspects of PTC software. There's also the PTC App Server portal for knowledge articles and suggested techniques. And there's also the location for the release notes so that you can get enhancement details on new versions of the software. Okay. Please don't forget, if you're looking to purchase Creo, that during the month of March, TriStar has a time-limited special offer. Receive 40% off of Creo products. And then finally, explore PTC certified training courses at tristar.com/PTC-training. Here you can find courses near you and reserve a seat, and you can also look for virtual training courses to come. So again, thank you for your attendance. We really appreciate you joining us this morning, and we look forward to you joining us for our upcoming webinars that you can find at tristar.com. Thank you again, everybody. This concludes our webinar.